Okay, we are starting on this chapter, techniques of differentiation. Before we start the actual differentiation, which actually some of you, most of you would have done simple differentiation at say in secondary school, let's go through some preliminaries. Some preliminaries in terms of limits, let's define some limits. Right limit essentially is the value as x approaches that value a from the right. Left limit is as approach, this is from the right, that means a plus, and this is from the left, a minus. Let's be a bit more concrete. Say for example, fx is 2x plus 1, and we want to find, say, the right limit, that means limit as x tend to, say, let's use the value 0 of 2x plus 1. Correct? Now, this means that we approach it from the right here. That means x is a little bit more than 0. A little bit more than 0, and that means x is 0.000001. A little bit more only. And I think as it comes nearer to 0, it's quite obvious that it will still end up as 1. The left limit then is as x tend to 0 minus of 2x plus 1. I think it's quite obvious. Also, now this time is from the left, 0.00001, right? Then it's still a very, very small value from the left, and then the limit is 1. Then you may say, actually, it's so obvious that the left limit and the right limit are the same. Now, if the left limit and right limit are the same, there is this condition. If you see here, if this is the right limit, and this is the left limit, if they happen to be the same and is equals to a value k, where k is a real number, then we say, okay, let's not talk about left limit, right limit. Then actually the limit actually exists, all right, and the limit is actually this specific value k. And for the example just now that we talked about, right, limit as x tend to 0 of 2x plus 1, all right, is actually 0. All right, and it exists. So we may say, oh, okay, it's so obvious. Good, you're right. Most of the time it's obvious, but let's use one more example. Let's consider the expression 5x minus x squared. Determine if 5 minus x squared exists, stating its value if it exists. Let's be a bit scientific about it. So let's look at the left and the right limit. Left limit means what? It means it approaches the value 2 from the left. That means it's 1.99, 1.999, 1.99999. So actually, if you look at the notes carefully, the GC has every ability to do this for you. If you can see from 1.9, 1.9 to 1.999 here, all right, then it approaches, you can see it approaches the value 6. Then what about from the right? The right means it approaches 2.1, 2.01, 2.0001, etc., etc. So if you can see here, the GC has the ability to do it. Right, so you can see it approaches very nicely to 6, approaches very nicely to 6. And some of you will say it's super obvious. And you are right. All right, in this case, it is obvious. And whether it approaches the value from 2 minus, that means from the left, or from the right, you will get 6. Hence, surely the limit exists, and the limit is actually 6. Obvious enough? And I think the graph will also tell you that. If you can see the graph here, if you can take a look at the graph, this is the graph of 5x minus x squared. You know it's a quadratic graph, it's a set face, and you can see even it approaches left and the right. That means here, it approaches the value 6. Correct? It's a continuous graph. And therefore, you can observe that the graph is continuous at x goes to 2. So this limit actually is 6. Super obvious. But in the next example, you will realize that sometimes you don't have a limit. Right? We'll take a look in the next example.